All right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone.
Morning, sir.
How are you today?
Fine.
Very good today. How about you?
I'm fine, thank you. Okay, did you study for the unit test? Yes? Did you study for unit test? Are you ready?
Inshallah ready, sir.
Inshallah ready, sir.
Okay, good. Okay, before we start our lesson, let's pray first. Pray, begin. Amin. Okay, now only 8 students here in the classroom. Let's wait a couple of minutes for the others to join. Let's wait for 1 minute. Okay, while we are waiting, can you please fill in the attendance in the description of the groups? You can find the link of the attendance. Please, everybody, go to the link and fill the attendance. So the unit test we will do in the non-video conference lesson, which is the second lesson. In this first lesson, I'm going to continue the topic for the second chapters today. So let me share my screen. Okay, good. Can you see the screen?
Yes, we can, sir.
Yes.
Yeah. Can you see how many students now in the classroom? Now only 12 students. Okay, no problem. We're going to start the lesson today. Okay, so welcome to chemistry lesson 11. Is 11 August 2020. So this is the lesson for the new topic that we are going to start today. Our new topic is one of the fundamental topic in chemistry, which is very important, as we know. It is about atoms. So mainly we are going to discuss of the structure of the atom in this topic. So this is chemistry number 11 lesson. So don't forget to fill the attendance. Okay, I think all of you already fill the attendance. So this is our topic. It is about atomic structure. And then this is the objective of the topics. We are going to explain the role of chemistry. Sorry, this is not the objective. It is not saved. Okay, actually the objective, this is the last lesson. The objective of this lesson is the learning about the structure of the atom and also the subatomic particles. As we know that we have subatomic particles inside the atom, which is called as the proton, electron, and neutron. So mainly we're going to talk about that one. Okay, let's start with this one. We're going to start with the word atom here. The word atom is very important. What does it mean? Is atoms. Firstly, all the scientists have accepted that the smallest part of the substance are called as the atoms. Okay, so it is very, very, very small. Yeah, even you cannot imagine how small is the atom. Although in this picture you can see the atom, but actually you cannot see the atom. It's just for illustration that the smallest particle here in the substance is called an atom, but actually atom cannot be seen by naked eyes. So you need some equipment to see even the behavior of the atom. So it is the smallest part. Yeah, this is important. It is the smallest part of the particle. Atom itself is coming from the Greek language. Yeah, it's coming from the Greek language, which is called as a atomos. Atomos means indivisible. Yeah, atomos mean indivisible. So in the ancient time, people think that atom is indivisible. You cannot divide anymore the atom. But later on, we will find out that in the atom, there are subatomic particles also, which is called as a proton, electron, and neutron. Later, we are going to see that. But at the beginning, they say that every substance have a very small particle, which is indivisible, which you cannot divide it. And we call that one as atomos in Greek language. So in English, we call this one as an atoms. Yeah. So atom has mainly two parts of the atom. The first one we call as a nucleus. So this nucleus is the one in the center here. The red one is the nucleus. But don't think that the color of the nucleus is red. This is just for the illustration. Yeah. So the one which is in the middle we call as a nucleus. So this one is called as nucleus. And then nucleus are surrounded. Nucleus are surrounded by the particle called as electron. So this blue particle, and don't think also the electron color is blue, this is just only illustration, yeah. But this blue particle here in the picture, it is called as the electron. So there are two particles, mainly nucleus and electron. Nucleus is in the center of the atom, and electrons are rotating around the nucleus, and it is rotating in very high speed. So actually this is moving, yeah, the electrons are moving. Okay. For example, here we have oxygen atoms. Oxygen atom here is one of the most common atom here. This is not oxygen elements. Yeah? We are talking about the oxygen atoms now. We are talking about the smallest particle of the oxygen, which is oxygen atoms. As I told you before, we have subatomic particle. Yeah, we have subatomic particle. What are those subatomic particles? The first one is called as a proton. The second one is neutron. The third one is electron. As we can see in the previous slide, here we have electron and nucleus. But how about the proton and neutron? Where is it? Where is the proton and neutron? Actually, proton and neutron is located here in the nucleus. So in the nucleus, we have proton and neutron. So actually here we have three subatomic particle. Nucleus is not subatomic particle, yeah. Nucleus is not a subatomic particle. It is a place where proton and neutron are located. But the subatomic particle is the proton, neutron, and electron. We have three subatomic particle. Proton is the one which is positively charged. It is positively charged. Neutron is no charge, or sometimes called a zero charge. It is neutral. Yeah? And electron is negatively charged. Yeah. For example, here in the oxygen atom, we have H proton, we have H neutron, and we have H electron. Okay. So this is called a subatomic particle. Again, another explanation about the oxygen atom. As you can see here, the proton and neutron are located in the center here. Yeah, the proton and neutron here located in the center. Yeah, as you can see, proton and neutron are located in the center. So that's why we call this place we call as nucleus. Yeah, this place are called a nucleus, and we have electrons are rotating around the nucleus. So totally here we have the different facts of the electron. In this fact we have 2 electrons, and in this state we have 6 electrons. So if we total this, we are going to have 8 electrons. As we can see in the previous slide here, the oxygen atom has 8 electrons. Okay. So this is again another example of subatomic particle. It is for carbon atoms. Yeah, carbon atom, carbon 12 atom. It has a proton and neutron here. As you can see, the proton is the positive one, and neutron is the white one without the charge. It is zero charge, neutral. It is in the nucleus, as you can see here. Yeah, and we have the electron here. Electron which is rotating around the nucleus. This is also electron, this is also electron. As you can see here, the electron is negatively charged. Yeah. Good. Let's continue. Okay, now we're going to talk about the atomic terminology. Okay. What is the atomic terminology? There are some terminology about atom that you have to know. Okay, the first one is called as the atomic mass number. Atomic mass number. So it's talking about the mass. Okay, it's talking about the mass of the atom. The mass of the atom. Okay, and it is denoted by A. Yeah, it is denoted by A. And we have also neutron, it is denoted by N, neutron. And we have also proton number, or sometimes it's called as the atomic number. Proton number or atomic number, they are the same. Yeah. If you are using proton number, then it is denoted by P. If you say atomic number, it is denoted by Z. But they are the same, the number are the same. Proton number is equal to the atomic numbers. We have also charge. Charge, it is the one that will make the atom have a charge. Yeah, charge can be positive or negative or zero, a neutral charge. Yeah, this symbol will tell you about the electrical properties of the atom, whether it is a positively charged, negatively charged, or neutral. It is denoted by Q. Yeah, charge is denoted by Q. And we have also the number of electron. It is denoted by E. Yeah, this E is denoted by the number of electron in the atoms. And we have some of the formula here, which is important in calculating the number of proton, neutron, or the mass number. As you can see here, A is the atomic mass number. Atomic mass number is equal to proton plus neutron. See this formula? So this atomic mass number, the number which is in the left side, left upper side of the symbol, yeah, this A is equal to P plus N. Or we can change P with what? Z, yeah. Also can be Z plus N. This is the same. P plus N or Z plus N, yeah, because the number of P and Z is equal. Okay. The next one is the charge Q. As we can see here, we can find the charge by the formula P minus electron, or sometimes we can change the P with the Z. So Z minus electron. So this P minus electron will give you the Q. So for example, if the P is 3, electron is 2, so the Q will be positive 1. Remember, when you are talking about the Q, you have to put positive or negative. Yeah. So it's, don't write only just the number, but you have to put positive or negative. Okay. Is that clear about the atomic terminology here? Do you have any question? Clear, yeah? Okay, good. If it is clear now, let's continue. Then, okay, now there is an example here. Can you fill in this blank, please? Fill the one which is blank here. Okay, give you a couple of minutes to fill in the blank. Okay, finish?
Yes, sir.
Okay,
Yes, sir.
let me ask Dimas Raihan Gifari.
Yes, sir.
What is the number here in the first row?
The first is 26.
Good. This is 26. Oh, what's that here?
This is 22 because Z equal to P.
Good. Okay. Another Damar. How about this? The second row, Damar.
Is 13.
Okay. This 13. Sorry. It is 13. Good. How about this?
Is same 13.
Okay. This is also 13. Okay. S. Ian Huga.
For the P is 16.
Good.
For the Z is, and then for the A is 32.
Good. This is 32. Very good. Yasin Arumi. For this last row. Yes, are you here, Yasin? Yasin is not answering. Let's go to Raditya.
Yes, sir.
Yes, how about this one, the last row, Raditya?
35.
35 here.
Yes.
Good. How about this?
80.
This is 80 here. Good. Very good. So everybody understood, right? How to find this number V, N, Z, and A. I think it's very easy. Yeah? Only subtracting and summing the value. So it's not very difficult. So this is the answer, the solution of that question. Okay, now let's come to the next thing. The next thing is we call as a ions. Okay, what is ions? Ions is the electrically charged particle. Electrically charged particle. So ion is also a particles like atoms, molecules, or atom and molecule, yeah. And ion is a different particle. This particle have an electrically charged, yeah. What does it mean is electrically charged? Electrically charged can be two types. The first one is cation, we call as a cation the first type, or it is a positively charged, yeah. So this is cation, the positively charged of the particle, or it is anion, the negatively charged particle. So we have the positive, we have the negative. If it is positive, called as a cation. If it is negative, it is anion. Okay, how it is become cation? If the number of proton is bigger than electron, yeah, if the number of proton is bigger than electron, then it's become cation, which is positively charged. If the number of proton is smaller, yeah, if the number of proton are smaller than number of electron, then it is become negatively charged, yeah. And we have also a neutral atoms. If it is neutral atom, the number of proton and electron are equals. So it is not a charge. Yeah, if it is neutral, it is not, sorry, it is not an ions. It doesn't have the charge. Yeah, if it is neutral, then it is not an ion. This is wrong, yeah. The written is not like that. It must be written like this, neutral. Yeah, not neutral, but neutral. Okay, I think it's clear for the ions. Yeah, it's clear, yeah, it's not difficult. Okay, let's move on. Okay, now we have some example again here. Let's fill in this example. Fill in the blank. Find the charge and ion type of atoms. All right, is it finished?
Yes, sir.
Good. Okay, let's see. We have now Arsha Gipari, the first one.
The charge is cation and ion is I don't get the ion, sir, but I get the charge.
Actually, what you say is the ions. The name of the ion is cation. Yeah. How about the charge? Okay. Fauzan Ahsani, can you give me the charge?
2.
Yes.
2.
Yes, it must be positive.
Positive
Don't
2.
forget to put the positive one because it's the charge. Good. Hafiz Ilmi, the second one.
The charge is positive 3.
Good. Positive 3. And it is?
And the ion is cation.
Cation. Good. Cation is also. And another one, Naufal Rizki Sufyan.
Yes, mister.
What is the charge here?
-2.
-2. Good. What is the name of the ions?
Anion.
It is anion. Okay. Okay. The next one, Septian Kamil. What is the charge here?
Sir.
Yes. What is the charge here?
0.
It is 0. Good. What is the name of the ions?
Neutral.
Yeah, there is no the name. Yeah, this is not ion. So we can say that here is neutral. Good. Okay, and the last one, zinc. What is the charge here, zinc?
Me, Mister.
Yes.
Okay. The charger is -1, and then the ion is anion.
Yes, this is.
Yes, thank you, sir.
Thank you. Okay. It is clear? Everybody, can you get? Do you understand? Good. Okay, let's move on. So this is the solution. Okay. Another thing is we're going to learn about the isotope. What is isotope? Isotope is the atoms that have the same number of proton but different number of neutron. Remember this symbol, yeah? This is carbon, carbon, carbon. This 12, 13, 14. So what number is this? 14, 13, 12. What's the name of this number?
Mass.
Yes, this is atomic mass number, yeah? Atomic mass number. Don't forget, this is the name of the number. How about this one? 6. What is the name of this one?
Proton.
Huh?
Number or proton or electron.
Number of proton or electron. What number is this? This is called as atomic
Number.
Atomic number.
or the other name is
Proton.
proton number. Good. It is atomic number, or it is called as the proton number. Yeah, they are the same. Yeah, atomic number or proton number. As you can see here, these 3 different atoms, they have the same number of atomic number, the same number of proton. Yeah, they have the same number of proton, but now let's calculate what is the number of neutron in each of these particles. What is the number of neutron? How to find the number of neutron?
Atomic mass number is
12 kurang 6, 13 kurang 6, 15 kurang 6.
So neutron will be equal to what?
Atomic mass number
Atomic mass number minus atomic number.
A minus B, isn't it?
Atomic number.
Yeah, atomic
Yes.
number minus proton. Yeah. So this number in the upper part will be subtracted with the number lower part. So let me put this in the middle. Okay. Let me put with different color here. The white one. Sorry, which color? Green. So what is the number of a neutron here? This is 7, isn't it? Sorry, not 7.
6.
It must be 6. Yeah, here is 6. Here, in here, it is 7.
7.
15 minus 6. This one, 8.
8.
Okay, as you can see here, guys, the number of neutron are different. So the number of neutron are different, but the number of proton are the same. So this kind of atoms, they are called isotope. Okay, this kind of atom, they are called as isotope. Isotopes are generally the same atoms, the same atoms. So for example, this one, all the same. All of them are carbon. As you can see here, the symbol are the same. All of them are carbon. But the difference is this is carbon 12, this is carbon 13, this is carbon 14. Yeah, they are different carbon, but they are still carbon. So because they are the same element, they are the same atom, so they will have similar chemical properties. Okay, this is very important. They will have the same, similar, or the same chemical properties. So chemical properties are similar or the same between this carbon 12, carbon 13, and carbon 14. But the physical properties will be different. Yeah, physical properties will be different. Chemical properties the same, physical properties different. Yeah, so this is the importance of the isotope. Do you have any question about the isotope? So they have the same number of proton, but different number of neutron. Obviously, if the number of neutron are different, then the number of mass also will be different. They are the same atom. Yeah, they are the same atom. That's why they will have similar chemical properties, but they will have different physical properties. Okay, good. Another things, other than isotope, we have isotone. Yeah, now it's different thing. Isotone are different. We have isotope. Now we have isotone. Okay, what is isotone? Isotone is atom with the same number of neutron but different number of proton. So, for example, here, this example. Something happened here, something strange here. Yeah, it must be like this: P 15 here and 31 here, and S here 32 here and 16 here. So it is the file is broken. Yeah, it must be like this. As you can see here, let's see what this one. This P have the number of proton 15. This S have number of proton 16. So they have different number of proton, isn't it? They have different number of proton. The proton number are different, as you can see from here. Let's calculate now the number of proton. The number of neutron. How about the number of neutron in here in P? It is
16.
16.
Here, the number of neutron is 16. Over here, what is the number of neutron here?
16.
16.
It's also 16. Good. So that's why they will have the same number of neutron. Yeah, they have the same number of neutron but different number of proton. As you can see here, the number of proton are different. One of them is 15, one of them is 16, but the number of neutron are equal. So if it is like this, we call that one as isoton. Yeah, we call this kind of atoms are isotons. Now, what is the difference with isoton and isotope? In isotope, they are the same atoms, isn't it? Just the difference is the number of mass, carbon 12, carbon 13, and carbon 14, as you can see in the previous slide here, carbon 12, carbon 13, carbon 14. So all of them are carbon. If it is isotope, they are the same atoms. In isoton, there are different atoms. One of them is phosphor, this P atom. One of them is S, sulfur atoms. So there are different atoms. That's why, because there are different atoms, so of course there will be completely different. There are completely different to each other. Not like the proton. In proton, we know that the chemical properties are the same, right? let's back to the proton. Proton have the same chemical properties or similar chemical properties, but different in physical properties. In isoton, they are different completely. Either it is a chemical or physical properties or characteristic, all of them are different because they are different atoms. One of them is phosphor here, it is phosphor, yeah. So that's why this is will be different because this is phosphor, yeah. And one of them here, it is sulfur. So sulfur and phosphor are different, yeah. Phosphor and sulfur are different, so that's why they have different chemical and physical properties. Okay, clear is this? Okay.
Yes,
Okay. Do we still have any? I think this is the last one. Good. We have under 3 minutes. So this is what I want to explain you today for lesson number 11. So mainly we're talking about, let's take a look again, what we have already talked. Today we talk about first the atoms. What is the atom? Okay, we talk about the definition of the atom, the smallest particle, and it is coming from the Greek language, Atomus, which means indivisible. And we talk about the part of the atoms. We have nucleus and we have electron, and also we talk about the subatomic particles, which is proton, neutron, and electron. And we talk about the location of them. Proton and neutron is located in the nucleus, and the electron are moving around the nucleus. And then we talk about the charge. Sorry, before the charge, we talk about the atomic terminology. We learn about atomic mass number, neutron, proton, or atomic numbers, and we learn about the charge also. And we find how to find the number of that one, proton, neutron, and electron, and also atomic mass. And then we talk about the ions. It can be two types of ion, positively charged cation, negatively charged as anion. And then we learn how to find the charge, whether it's positive, negative, or neutrals. And then we learn about two things, isotope and isotope. So this is what we learned today. Next lesson, we're going to continue still with this structure of atoms. Yeah, we're going to learn about the theory, atomic theory, in the next lesson, inshallah. Okay, for the unit task, after this, we're going to have the unit test. I'm going to share you the link of the unit test. And please, because I will not invigilate you by the Zoom, or I will not supervise you by the Zoom. You're going to do it by yourself. Please be honest. Yeah, integrity is important. Don't look at any books or any sources. Just do it the question. There will be 15 questions. You have 40 minutes to finish. All of them are multiple choice. Okay. Thank you. That's enough for today. Do you have any question again? Do you have any question? No? Okay, if it is not, that's enough for today. See you in the Thursday. So we finish for today. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.